All right, this is amazing. First of all, like first meetup back live in 2 years. I know, right? Wow, we kind of survived. So who here is here because of the Cloud Native Containers group? Okay, I actually recognize people who don't have their hands up right now, but I know you're part of the user group. I have been for like 10 years. And then what about the data on Kubernetes group? Who came through that one? Cool, cool. Okay, awesome. Awesome. So Bart couldn't make it because he's back in Spain. But Robert is also with part of the data on Kubernetes team. He was in here. He'll be back. And he's our second presenter. Chichu is our first presenter, I guess. And I'm the day 0 presenter, I suppose, if I'm the -1 presenter. But anyway, I just wanted to reintroduce John Starmer is my co-organizer of the Cloud Native Containers user group, and Bart and Sylvain and Robert and I also do this data on Kubernetes community, and I'll tell a little bit more about that. There's Robert. And so this is me. I'm with Cockroach Labs. I run developer relations, and it's a company based out of New York. I'll talk a little bit about more about that later. And I'm also a CNCF ambassador, which is why this is one of the largest, if not still the world's largest CNCF user group, maybe. I don't know, haven't counted some of the other ones, but we have over 7,000 members, and it's a pretty awesome user group. So a lot of this is being recorded and will be watched later by awesome members of our user group. John runs head of education for the Cumulus Technologies, which is why he gets to do his job out of Maui. We're all very jealous. In case you're wondering why he looks so relaxed and tan, that's why. And also why it's so much lighter over there and the sun isn't going to set. And John is, even though he's moved to Maui, he's been able to do a lot of stuff behind the scenes and help us keep this user group rolling, and he does all these beautiful graphics and all of that. So if you didn't get one on the way in, I have like one more medium, I think, and 2 more larges, and like 2 XLs, and a couple of fitted sizes for the t-shirts. Also classic swag. CNCF sent me boxes of these Kubernetes fidget spinners to bring to meetups, and I've been bringing them ever since, and I still haven't run out. So you got some classic swag, because this thing is like $8 on the CNCF store if you buy it, and they're really solid and really heavy. If you have little kids, watch it. They go and break glass as they fly across the room. They look like they'd be fun to toss, and I suppose if you're between the ages of 2 and 35, maybe they are. Also, you know, the cockroach stickers. So I'm going to just tell you a little bit about cockroach, because many of you didn't realize that that was actually a cockroach until somebody was like, oh, I see, cockroach TV, now I understand. Yes, it's a cockroach. We just try to not gross people out with our logo. We just try to, you know, have a cuter version of it. But since you're all going to be wearing this shirt, I'll just tell you really briefly.
You have an NFT also?
Do we have a what?
NFT?
And no, you know, one of our customers makes NFTs. That we're not an NFT, we're a database.
No, of your.
Oh, we do. Oh, we don't. Ideas. We have some of my colleagues here in the middle row, Joe and Hirsch. So yeah, I know, right? I was thinking we were talking about Bitsky, one of our favorite customers who's an NFT shop. Anyway, it's a distributed SQL database. It was architected, well, I'll get into that in a second, but it scales fast, survives anything, thrives anywhere, everywhere, just like a cockroach. But distributed SQL is really cool. It was a database that was built on Kubernetes. So it's a really cool Kubernetes use case, not built like next to Kubernetes, but like built on Kubernetes. So it's the database optimized for running stateful applications in the cloud, really. And distributed SQL is very, very cool stuff. It's also, like Kubernetes, the other largest Go project written in Go. And so really, really creative. The founders came out of, oh no, I'm frozen again. Came out of Google, but before that, they were college roommates at Berkeley. Who's heard of the program GIMP? Oh, okay, yeah. So when they were at Berkeley, and Spencer was a computer science major, and Peter was computer science and EE electrical engineering, they started the GIMP program, which is arguably more famous at the moment than Cockroach. Probably at the end of the day won't be more impactful, but the GNU image manipulation program, and it's kind of still has a shelf life. So that's where they started, still best friends. And then when they were at Google in the early days of Spanner and Borg, and that's kind of what Cockroach morphed out of, they, hooked up with Ben Darnell and all worked together. And then eventually was like, there's this cloud thing and the Kubernetes thing is happening, and the database really needs to go beyond what Spanner can do. And we're going to write something called Cockroach. So they started when they were at Square and they wrote it, but Square didn't want it. So they're like, okay, let's open source it. So it's all, you can check it out. It's on GitHub. It's really, really cool. We say build what you dream because the possibilities are endless. And we've got a little challenge for you. So the cool thing about being open source is we're trying to get back to free as in beer. So we actually have a CockroachDB serverless that you can try. Just go to our cockroachlabs.com. So you can, if you've got an application, you need a database, and you can try us for free up to 5 gigs of storage, and at the moment 250 resource units. So it's a lot. You can get a lot done with that. And then beyond that, you would just pay as you go. I mean, you can still use it. It'll slow down. You can be like, do you want to put your credit card in if you want to? But you don't need to do all that to get started. So we use it for hackathons. We do a lot of cool stuff with it. So I encourage you to try it out, play around with it. So cockroachlabs.com. So back to the other part of the user group, the data on Kubernetes. I promised that team more good stuff coming up. If anyone is wanting to speak at this meetup or wanting to speak at a day 0 event at KubeCon, first of all, how many people are going to KubeCon? Okay, nice. Well, if you're not going, but you want to do it virtually, they're doing the DOK Day 0 event, and the call for papers is still open. It's open until September 1st. I think I'm on the track chair committee again, so I will be reviewing some of these. So please be mindful when you write your abstracts. Make them entertaining, not too long, and something that I would want to read 400 of. So and catchy titles. So yeah, and we will prioritize first-time speakers. We'll definitely prioritize women, underrepresented minorities. We want people to get their foot in the door who haven't had a chance to yet, and it's a very low lift. If you want to do it virtually, pretty easy. You can do it for your house. So if you go to the Data on Kubernetes site, you can find how to submit your talk if you'd like to. It doesn't have to be on Kubernetes, but it's stateful applications in the cloud is essentially what they're going for there. A little bit more about the community. If you want to join the Data on Kubernetes community, it's a rocket ship. What they did with virtual meetups in the last 2 years has just been amazing. So it's an international community. It's a great community to be a part of. And I've had a lot of fun. They also did a Kubernetes report, which it's funny because the Cockroach did a Kubernetes report also, and the CNCF did a Kubernetes report. And all 3 of us basically found very, very similar data. Their reports, all the reports are free if you want to download it. But they interviewed a lot of really interesting end users. And this was last year's report. There's a link to it. I'm going to put all these links in the meetup page. But also they're putting the survey around for a 2022 report. But if you want to check out what a lot of users are doing with Kubernetes from last year, you'll be surprised. The number of production running applications just skyrocketed in that 1-year period, a lot more than we thought. Obviously, big learnings were what some of us already know. It's still hard. The need for operators is huge. There aren't enough out there. Everyone's writing their own, and then they're getting stuck because you're like working at Mercedes, and all of a sudden you've got to write an operator for your Kubernetes, situation to run stateful applications on Kubernetes, because natively that's not so easy. So all of that is things we know, and it was also interesting to hear that everybody was having the same problems. So that's a little bit about the DOK day. We have 2 speakers. Robert's going to go second, and Chishu is going to go first. And by the way, Team Argo, one of my favorite projects. Who here is from Argo? Okay, awesome. When we network at the end, if you want to talk about Argo, it's kind of one of my favorite projects. If you're looking for your next open source side hustle, it's a great community to join. I absolutely love it. Plus you get those cute little orange octopuses on your shirt, octopi. Also want to introduce Frederick. We have a celebrity in the house and one of my favorite community people. Frederick, it was just announced yesterday, is the new co-chair for KubeCon Detroit, North America. Yes! That's fine. He's also an expert in security and spiff, and I got to moderate his session at KubeCon in Valencia, and it was a pleasure. I learned so much until my head exploded. It was really good. He's also the author of the famous book, The Bottom Turtle, The Last Turtle, The Bottom Turtle. The Bottom Turtle. Okay. Oh, I had it right the first time. It's a great book. I stalked him in KubeCon LA and got him to sign my copy. Anyway, congratulations. That's huge. I mean, there's only two. He's the co-chair. That's awesome. So well done, my friend. Well done. And thank you for being an awesome member of the community for 7 years. Okay, so you want to just plug your laptop in, and if you didn't get your stuff, I'll be out there for a minute, but don't climb all over each other. You can just wave me down and I'll come and find you. You know what? I'm gonna probably not need to, actually, let me take my power cord. Or do you need to, you want to use it? You can use it, but do not let me forget it.
Right.
Wait, is that the same? Yeah. Okay, go for it. But I'm classic for leaving that places, so please. As you can see, that's not even.
I don't want to
Mac
run out of battery in the middle of the session.
Oh, yeah. By the way, don't lose your power cords because the Mac real one is so backlisted, like months. So that's aftermarket. No, it's bad. Thank you.
All right, cool. So hello everyone. Good evening. I'm Shrivardhan. They also call me Chichu. I work for the operational data lake team at Intuit. And I'm here to talk about how we use Druid to power AI at Intuit. Firstly, I'm going to start off setting some context on how Druid fits the use case we are solving for, and then move on to the fun part of actually installing Druid clusters with just one click. And then speak a little bit about our journey and some of great learnings of running stateful workloads on Kubernetes, which is the theme of the Data on Kubernetes community. So let's get started. Here's the agenda. I'm going to talk why Druid, talk about the components, and we're going to, that's a demo. And here are some learnings about what we do, how do we handle data and statefulness and monitoring and alerting, and how we, the journey of our performance tests, and some cool numbers to show how great Druid runs. And then finally head on to question and answers. So please feel free to ask any questions during my talk. Let's get started. So why Druid, and how does it fit into Intuit use case? So at Intuit, we have a lot of services, microservices, platforms, and you won't stop sharing.
I'm gonna do a direct
Okay.
to this.
Pardon me.
Inception. Yeah. I stopped. I think they're cool.
The D in Druid stands for Druid.
Cool. So yeah, we were here, and I was talking about how we have a lot of services and different kinds of platforms at Intuit. So each of these services and platforms generate a lot of data, which are like structured, unstructured, trace data, metric data, events, and all of this flows into what we call operational data lake, and that's the team I'm in. And we publish it, enrich it, and make it available for querying, which is used in several use cases like finding security or compliance issues and observability, finding driving development velocity, like reducing costs and all of these things. And we have a large variety of databases that support all of operational data line. One of the most important part is that most of this is real-time data, and it is we want to run streaming analytics on it so that we can proactively find like what services are running bad, and reduce the MTTR and MTTD. And that's where Druid comes in. So as I said, like we run a lot of operational analytics, and one of the most important things for it is like ingesting streaming data to run machine learning models on it. And also we want to slice and dice super fast. Like we, talking about metrics, there are dimensions and metrics and traces. So we want to be able to slice and dice and do aggregations on the fly, so that we can find out what's wrong with the system. And we also want to support a large variety of data formats like JSON, Avro, whatever is the data format we are getting the metrics or traces in. And obviously there's high cardinality because of the amount of microservices we are running and the kind of systems we are dealing with. So Druid is kind of tailored for all of these use cases. It's a mix of like it's a time series database, and it also has data warehousing capabilities where we can have hot and cold tiers, and we can have hot and cold data. We can like ingest batch data or ingest streaming data, all of that. And the search systems capabilities like Elasticsearch, where we want faster queries on index data and so on. So this Druid by design is a mixture of all this, and that's why we are used for the operational analytics use case at Intuit. We thought Druid is a good use case, and that's where we started our journey about a year or so. And I'm super excited to talk about how we run it on Kubernetes. All right, let's get to the fun part. This is the different components. I really like this diagram. This is one of the first blogs I read, and this by Anastasio. And yeah, so this very neatly explains the different components of Druid and how they interact with each other. I'm just putting this up here because a lot of people are new to Druid, and I want to highlight the problem of it's not just about running a database. It's actually a collection of different microservices that we want to run together in tandem in a distributed fashion on Kubernetes. So in the middle, you see a set of external dependencies that are not run on Kubernetes. Maybe, yeah, we do run Zookeeper, but the other ones are like managed services, and Intuit is mostly AWS, so we run it on AWS. Let's see how data flows in and how a query flows. So the middle managers are the workhorses. They have the tasks, and everything is a JVM process. So we can get in batch data, streaming data. They get the data and store it in a format called segments. That's the most atomic part. And then it's published to the deep storage. The historicals pick it up from there, and they are the ones that do the most of the querying part. Middle managers are for real-time querying. Historicals are for like data that's already published. And then we have the masters, the overlords and the coordinators. They like say which segment goes where and what is to be dropped and what's to be loaded. And the brokers, I think the routers are missing, but they are the ones which actually service the client queries. So we have about 6 microservices that are independent of each other, and but run together, and that's what is called a Druid cluster. All right, right. So this is the part before we run Druid on Kubernetes. There are some things like the external dependencies, some plumbing we need to set up, and that is like we need to have a K-test cluster, obviously. And the RDS instance, like I said, is running on AWS, and we have S3 buckets and a Zookeeper. So So by Intuit, we have this nice model where each of the Kubernetes, we call it Intuit Kubernetes service, and it runs in its own AWS account, which is connected to a product development AWS account where the databases reside. And this is kind of the setup in most cases. So yeah, the cluster talks to the IDS instance on the PD AWS account and S3 buckets as well. And we run Zookeeper along with Druid. This is like an added microservice, the seventh one. And we run a Zookeeper ensemble like in a HA fashion. And yeah, it's all packaged together. Okay. Yeah, when we want to run something on Kubernetes, we need an operator, and operators are it's a operator pattern wherein we write some code, and that becomes the control system that watches and manages the state of an application we want to run. And Druid operator, this is an open source repo that we adopted and made a couple of changes to fit into use case. I think this is contributed by Splunk. Yeah, it's based on Kube Builder. It creates a custom resource type named Druid, and it supports rolling deployment and upgrades. And referring to one of DOK's talks, I think there are like 5 principles that an operator has to support. And I believe Druid operator does most of it, like 4 levels of those 5 principles. And the last one is like autopilot, which is like which manages auto scaling and like totally autonomous running of a Druid cluster. I don't think it is there yet, but with the tools in Intuit, we have somehow managed it to do all 5 principles. So it does the app lifecycle, like it manages the applications, like all the different microservices we saw. And it also manages the storage, like the PVCs, the volumes, and it takes care of the creation and like removal of the storage devices. And it also provides out-of-the-box metrics. Graceful shutdown. This is something we contributed to the operator, and I can talk about it later when we look at the cluster. All right, this is how we're going to deploy. So at Intuit, obviously we have Argo CD in everything we do. So that's the CI/CD, and then we use Customize to manage the Kubernetes spec, and Argo CD. This command is similar to a kubectl apply, and once I do this, let's see. Yep. So you can see that it's how to sync. So basically, we have a set of YAML specs, and that deploys the operator along with the root cluster. So let me just click sync and head over to the specs while the cluster boots up. All right, it's syncing. It takes some time. So I'm just going to go over some of our repos and how we do things. So this is a Druid repo. Basically, here is where we get the open source image, add whatever things we want to add, and check it for security or compliance, and then publish it to our Artifactory. And this is the deployment repo where we have all the YAML specs. And as you can see here, we have all the different services that I just spoke about, the historicals, brokers, the overlords. And then this is the common properties of the cluster. And you can see the Druid CRD type. And it holds all of the annotations and log formatting, which are common to all the other 6 Druid services. Okay, that's the same thing. And this is how the customized files look like. We are bundling all of it. We have the CRD that's obviously accompanied by the role, a service account, and a role binding. And we also have the exporters and the collectors. I'm going to talk about it in a bit. And then we have the main cluster, and we have also the Zookeeper. And these are the patches based on the environment, like based on the environment, these patches change like the IAM rules and stuff. So this is how we have all of it. And once the Argo CD sync succeeds, this is what is going to be deployed. You can see that the operator is being deployed. Let me refresh this. Okay, looks like it's up, and I had the ALB endpoint ready. And we should see Druid running. So we just deployed Druid with a click. And I have just one ingestion running here, and this is like through a Kafka topic. Druid supports most of the formats like Kafka, S3, and you can even configure Hadoop or other cloud storages. And we're going to see if, okay, I think it's still starting up because we don't see the data source yet. Let me quickly jump back to the specs and show how we achieve HA. So HA for the Druid service is like we don't want any of the Druid service to go down because although they are independent, it might cause lead to data loss or holes in the data and stuff like that. So how we do it is we obviously have more than one of each of the type and like the replicas, and we use pod anti-affinity so that two services of the same type are not on the same node, like two historicals on the same node or two overloads on the same node. And then I think these are pretty standard Kubernetes constructs that we use to achieve it. Node affinity. This one's interesting because all of the different Druid services I spoke about has a specific memory requirement. So a router would not need a lot of memory. It's just servicing HTTP requests. So it's going to have like probably a M5 large kind of AWS instance group. Whereas historical, which is very memory intensive, should have a lot of memory, and we use something in the terms of R5 8x large, which has about 250 gigs of memory, I suppose, or more than that. So so what node affinity does is for each type, it puts it in the right bucket or right node type. And the third one is like the PDB, the pod disruption budget. And we make sure that during node upgrades or an outage or cluster upgrades, there's only one that goes down at each time. So it updates in a rolling fashion, and we do not have any query failures or data loss. Yeah, that's about it. Let's check on our ingestion if it's cool. Still not here. All right, it's still coming up. Not sure. Just let's give it a minute or more. Meanwhile, let me talk about the next thing I had. Right. Like I said, historicals are the ones which have all the data. The way it works is like once the middle managers read in the data, they create segments, and segments are pushed to the deep storage, and historicals load back. And we use PVCs to store all this segments. It's called the segment cache. And the reason for using PVCs is that whenever his historical goes down, it comes back up and asks the Zookeeper, which maintains the state, in this case, that what are the segments it has to load. And because we use stateful sets, the host name of the historicals is always the same. So let's say one goes down and comes back up, it has the same name. And that's how it, when it queries Zookeeper, it gets the its loading queue. And when the PVC is also loaded and it's not gone because it's not F middle. So once it comes back up, it has all its segments in the segment cache, and the uptime for a historical after a restart is super fast because of the PVCs. This is something we configured. Let's check on this one. I really want to run a query. Cool. It's still not up. All right. That's okay. Anyways, moving on to monitoring analytics. So now we are moving on to the learnings of how of what we learned from running Druid in production on Kubernetes. So yeah, Druid already has a lot of metrics about ingestion and querying, which helps us like monitor the state or like understand the performance of the cluster. But when we run it on Kubernetes, we want to be able to have control on what the health of the system is, or detect uh, resource utilization like the memory and CPU and so on. So what we did is we used a Prometheus collector interface pattern, and we created two things. One is called the collector and one is called the exporter. So the exporter is just an endpoint like this, which we configure as the emitter on the Druid configuration, and Druid just emits its metrics to the HTTP endpoint. Whereas the collector, what it does is it periodically queries the Druid REST API. Druid exposes a REST API, and it provides all the handles for the health of different applications, like the historicals and overloads. And it's different for each of them. For example, the overloads, it might just be a 200, I'm okay. But for the historicals, it is only okay when it has loaded all of the segments. So the collector basically does those HTTP calls and puts it back into our metric collection system that we use Wayfront. And that's how we are able to like actively monitor and alert on the state of our Druid clusters, and we have multiple running in production. All right, this is another I'd say improvement that we have built around Druid, and it's called the Root Proxy. There are several reasons why we came up with this design. One of the main one is authentication and authorization. Like at the end of the day, Druid is just a REST API and it provides like basic authentication. But we like when we run this in production and there are so many users accessing it and it's given its criticality, we thought we have to build some guardrails around it and also monitor the query patterns and see who are the users accessing it. And that's where we built in the authentication and authorization into the reverse proxy. This is a very thin service that runs outside of Druid, but can access all of the Druid clusters. It maintains metadata of all the Druid clusters, and it can parse, intercept, and query any of the Druid clusters intelligently. Based on whatever data source you query, it routes it to the right Druid cluster. All right. Yeah, this I think is the last part, our journey of performance tests. I just wanted to touch upon this because it's super important for us to know how we can improve the performance of our Druid cluster, just not by running random queries. We needed to tune the Druid cluster, and Druid has a lot of JVM configurations that we need to worry about. And there is no deterministic approach to say this is the right amount of memory for a given data source or a given workload. And because of our performance tests and the way we modeled it, we were able to uh, find a formula, I'd say, to deterministically say the segment sizing or determine the JVM memory config based on the TPS and row size. And also we made a lot of optimizations on the group by queries. So basically what we're doing is we have a test route using the ABGo, it's Apache Bench in Golang. And what we do is we capture user profiles, like the different kinds of user queries and it depends on what kind of data source is it, how big the row size is, or how frequently data is written to the data source. And we run these query profiles very so often to find out what would be the correct segment size for the data source. And recently what we are working on is like having a Gatling framework, and that would be a dedicated namespace, which would run these tests for every new data source that we want to onboard. And that would give us the optimal segment sizing and the optimal memory config for that particular data source. Let me try once again if I'm able to query this. It's really not working. Okay. Okay, these are some numbers. I think these were way higher during our tax peak, but this is in recent times. The Druid, each one of our Druid cluster does 2.5 billion events a day, and the P99 query response time is approximately 30 milliseconds. And the lag, and what I mean by lag is like mostly we have Kafka topics, and we have like 400 more events to process than that are already existing in the Kafka topic. So there is also another metric in terms of milliseconds, but I felt this is more relevant, so just putting it there. Cool. I also have this other. Okay. This is one of an IDE I found, which nicely shows how the pods and all the items the Druid cluster constitutes of. This is called lens, and here you can see all of them started about 30 minutes ago. That means I'm out of time now. And this is the production cluster. And yeah, like I said, there it all follows the node affinity, the anti-affinity, and PDBs, and you can see the persistent volume claims that have been created, and these are all managed by the operator. I can try running. I mean, you might have already seen a Druid cluster, but let me just run the query for the sake of it. Any questions up until now? Okay, if you don't, I'd like to show a small use case, the real one, where we use Druid and how cool it looks. So this is the dev portal. This is like a portal where every developer at Intuit comes to, and you can see the top anomalous assets we're showing, and this anomaly and the machine learning model runs and produces an anomaly score, and that's what is showing up. And these are called the home cards, and these are currently querying Druid to come up with this view. Let me see if I can find another cool app. Right, I had one open. So this is like a plugin, and you can see the number of interactions. Like these are based on Google Analytics, the metrics, and you can see the failed interactions and users impacted. And as far as the integration goes, right now we are able to alert on any failed interactions to the correct service owner, and that way we are reducing the MTTR and MTT. That's how we used to it. All right, questions?
Was there, Robert, you have a question?
Yeah, so do you guys use the default Kubernetes scheduler, or did you do anything special to make Druid run better?
No, we run on I mean, it's we've modeled it as Intuit Kubernetes service. I'm not sure what scheduler we are using, but as far as Druid is concerned, we didn't make any changes. It just runs on vanilla Kubernetes, whatever we have. Thank you.
what are the tools did you compare to evolve against?
We did compare it with Pinot and I think ClickHouse before settling with Druid. And I think one of the most important reasons was that it was in Java, and we were able
What
to.
is Java to do with it?
No, we wanted to be able to contribute back to
Okay.
and understand what we are running rather than having a black box and we don't know what it's doing. So
other languages you won't be able to contribute.
it was easier, I'd say.
Come on now. Java.
Right.
Legacy.
All right, cool.
Oh, we could have a whole meetup debating that, a whole thing.
Non-blogging.
Raise your hand if Java is your favorite language and your programming language of choice. Is anyone's love language Java? Okay, how about Python?
Maybe.
Okay, how about Go?
Java.
JavaScript, okay. Node.js
No.
in the same category. Interesting. Well, most of our technology, you can use whatever language you want. Okay, cool. So Robert's our next speaker, and it's funny that you mentioned ClickHouse. A lot of synergy going on today. Also a subject very near and dear to my heart, running stateful applications, especially databases on Kubernetes. I loved his abstract where he says, databases are perhaps the most resistant to the cloud native cattle, not pets model. It's been a while since I thought about the cattle versus pets. That was a huge, enter Randy bias and all those presentations. Lots of people giving themselves credit for inventing that term, but I loved it. I hadn't heard it for a while. So what does it really mean to run large databases on Kubernetes? So you're gonna have an example, another example. So that's a theme for today, and Joseph Sandoval, our dear community friend, called me up after he saw him give this talk, and he was like, Lisa, you've got to feature this talk. And the Peninsula, I learned so much. So I've been excited ever since then. And I thank you for driving all the way across the bay, over some bridges, down some peninsulas to get here.
It brings back fond memories of working at VMware.
Yeah, right.
Yeah, I worked at VMware for 4 years, so I had to do this drive. Yeah, so thank you so much. And yeah, thank you for setting up this great meetup. Thanks, Henrik, and all the Intuit shareholders. I'd like to thank them as well for the pizza. So yeah, I'm going to be talking about life in the herd, cloud native ClickHouse, and it is cool. I have a huge amount of respect for Druid. We're actually competitors, so which is great for you guys who are not database people. You have choice. There's also Pinot. There's also other products, but it's kind of cool to see how different people attack these problems. So yeah. Oh, actually, it's got the wrong thing. It should, because I did do it up in San Francisco.
This is fine.
I'm gonna put 2 days. So just a little bit about me. I'm a database geek. I've been working on databases for over 30 years. Actually, since 1983, and I just say over 30 years because I don't sound so old that way. I've been doing this for a long time. I started with mainframes in the 70s. So 20 different kinds of databases. I am not a database internals person, but I've just done just about everything else. The thing I've spent the most time on is probably replication. My day job is I run Altinity. In fact, here's us. We're an enterprise provider for ClickHouse. So we were first in the American market. We run a cloud service called Altinity.cloud that has about 80 customers on it. We run about 1,000 ClickHouse databases on it. We wrote the Kubernetes operator for ClickHouse, which is now probably, is used to manage tens of thousands of ClickHouse nodes at this point. It kind of surprised us. A lot of we use it ourselves. A lot of our customers use it. And then it turns out that one of the big Chinese cloud services for ClickHouse uses this Kubernetes operator, as do a bunch of community users, like eBay, for example. And then we have an engineering team. So a lot of what I'm going to be presenting here is really the kind of distilled experience of people on our team. I did not write the code for the operator. I write a lot of SQL. And then some Python when I have to. So that's the background. Yeah, the vision. How long have you guys been working on Kubernetes? It's like I've been doing it for 4 years. Anybody longer than 4 years? Okay, how about like 6? Anybody who's been doing it for 6? There was a time when, like Kubernetes was being introduced, and maybe, I don't know if this has happened to you, but you'd get some architect guy or gal come in and say, cattle, not pets, and this was sort of the deep insight that databases or whatever you're running, they were no longer going to be these sort of delicate flowers. They were all just going to be, there's going to be a whole herd of them. If one of them falls dead, hey, no problem. Another one will grow up to take its place. And so that was the vision, that you're just going to have databases in particular, and they're just going to look like this happy herd of cattle. There's one, sort of relaxed looking lady running them. And that is the vision. The interesting thing is that it actually kind of works. So, and I'm going to use dig into ClickHouse, but what I first wanted to do was just explain what ClickHouse is. How many people have heard of ClickHouse? Oh, that's actually not bad. We're making progress, but I think this slide is good. So how many people know MySQL? Excellent. Okay. ClickHouse is like MySQL, but it can do analytic queries. What do I mean by analytic queries? I mean, it can just rip through huge amounts of data and give you SQL query response in a second or less. So like ClickHouse, or excuse me, like MySQL, it understands SQL. Pretty much all the winners in this space speak SQL, like it or not. Like MySQL, it runs on everything. It is a C++ binary. There's just one of them is statically linked. It will literally run on everything from an Android phone all the way up to racked equipment with hundreds of nodes. It will run in the cloud, and it runs great on in containers. It's designed with a shared nothing architecture. So when I say shared nothing in databases, that means it's a bunch of servers with attached storage that communicate over a network. This is the traditional, starting about 30 years ago, this is the traditional way that data warehouses were designed. We're evolving toward decoupled storage and compute. I'll talk about that a little bit later. This is where we really depart, is we store the data in columns. So MySQL, if you have an invoice or you have, analytic data from web applications, for example, it's going to be stored, like if you have a message, it's all going to be in one row. All the fields will be in one place. So if you want to read one of the columns, you read all of them. Column databases store them in arrays. So if you just need to read 3 columns out of 100, you will only read that much. You only do that much I/O. It's a pretty profound change, and this is one of the things that really characterizes most analytic databases today. And it has some knock-on effects, aside from the fact that you don't need to read as much data because you only read the columns that you touch. It has enormous impact on things like compression because you get long run lengths with consistent data types, and it allows you to radically reduce your, in addition to just not reading a lot of columns in the first place, these columns become vastly smaller. And in some cases, the compression levels, I'm not making this up, you can actually get compression levels of 100 to 1 or 1,000 to 1 over the original data types. Those are extreme cases, but it has a huge impact. Another thing that ClickHouse does, like Druid, is, and other data warehouses, is extremely efficient at parallelizing queries. So these queries are basically designed, and I think we saw examples in the previous talk, to go, compute aggregates, to, count the number of unique visitors to a website per hour, something like that. So ClickHouse is very good at doing this in parallel, both across all the cores in, say in a single CPU, across all the CPUs available on a motherboard, and then across all the nodes available in a cluster, if you choose to distribute the query. And the execution is vectorized, which is because these columns are like arrays, we're going to split them up. We'll treat them as vectors, we'll split them up into pieces, and then we'll load those into memory and just, blast over them as fast as we can. And vectorized execution also, typically vectorized execution also includes the use of SIMD instructions when they're available and appropriate. So we use ClickHouse, that's a single instruction, multiple data. So allows you to get concurrency on conventional CPUs. So scaling, yeah, like Druid, it scales very, very well, and it's open source. Great license, you can use it for anything. And so it's become really popular. commonly used, all kinds of use cases. In fact, pretty much the same use cases that Druid is used for, things like web analytics. Think of like Google Analytics, that kind of thing, all the way to valuing financial assets, mark-to-market types of things, and then a bunch of stuff in between, like network flow logs, observability data, real-time marketing information, so on and so forth. That's ClickHouse. So it's a great database. It is we call this cloud friendly, or in the sense that it's good because it's just a single process. And that is a distinction to Druid, the thing that you saw. In ClickHouse clusters, you just have these little boxes, the colored boxes here, each represent a process that's running on typically on a single host. There's only one type of process. Now, you also traditionally have Zookeeper servers. Those are used to keep track of replicated copies. So this is simpler than Druid and some other architectures, but it's still complicated because you have a lot of pieces here. They're running, we may want to run them across availability zones. They're connected on a network. We have Zookeeper, of course. We need to load balance across these, stuff like that. So this is complicated. And in fact, these things are kind of a pain in the butt to set up. Just to give you a simple example, the DNS has to be consistent on every single one of these nodes. Otherwise, they won't be able to find each other when they're doing distributed queries. And then you get these bugs where, it's one thing, you'll get intermittent failures because one node cannot find other nodes. And you'll be, going through Etsy hosts for, like hours until you find out which one is wrong. So this is complicated. The cool thing is that operators have totally enabled Kubernetes to handle this very well. And like what you just heard with Druid, we wrote an operator for ClickHouse that is the Altinity ClickHouse operator, and it's pretty popular, as I said. And basically what it does is it reduces that ClickHouse cluster that you just saw on the previous slide down to a fairly short file that's typically, for sort of civilian versions of it, it's maybe 2 feet long. I mean, it's really pretty small. And this will set up something that might look like, that cluster over there, where you might have 50, even for a cluster that's not got too many nodes, you might end up allocating 50 or 60 Kubernetes resources. Because you'll have things like persistent volumes, you'll have claims, you'll have pods, you'll have stateful sets, so on and so forth, load balancers or services, I should say, configuration files. And this is a really, really good model. I think that I was pretty skeptical about running data on Kubernetes a few years ago. I got in a huge argument about this with the board of our company when I was first interviewing for the job. And they said, hey, we're going to run this stuff on Kubernetes. And I said, that'll never work. And the only reason I got the job was I offered to work for free. So, but because I was so wrong, this actually has turned out to be a really great model. And the reason is that it just allows you to bake in things like rolling upgrades in a way that that do it as well as a well-informed human would ever set these things up. They also react very well to things that go wrong inside Kubernetes. The resources are already out there. The operator can detect unusual conditions that can correct them. So this is a really, really good model. When we started, we had no idea about Kubernetes. It took us about a year to really get it to work right, but it's really turned out to be a great model. Just to illustrate the simplicity, this is YAML, and this doesn't look that beautiful, but the point is that this is regardless of how complex your clusters are, you're basically doing things like telling it, hey, where's Zookeeper? How many shards do I want? How many replicas? Ours tend to be more complicated than this because we will do things like set availability zones. So we'll have to, define node anti-affinity and things like that. But and we'll have to define storage. We'll have to get precise about versions. But this is really pretty manageable. We don't use any. I don't use any tools other than kubectl when I'm playing around with this stuff. It's really pretty easy to manage. And in fact, when you write the operator well, it doesn't have too many bugs. It does a bunch of great things. So ours does all of these things. other operators do even more. So for example, horizontal scaling. If I want to change the number of shards in my cluster, so shards are disjoint sets of data, all I have to do is change this number from 1 to 2, resubmit this through kubectl, and what will happen is the operator will see it and will say, aha, I need to make another shard, and that shard shall have 2 replicas. I'm going to create 2 more servers. By the way, this is coming up kind of new, so I better just manually move the SQL over, like the schema definitions over to these replicas, and bang, it's up and running, and it gets fed into the load balancer. It's great. Similarly, things like rolling upgrade. So with databases in particular, it's really important not to take them down and break applications. I think as people here are well aware, vertical scaling. This is a really interesting thing. We use EBS storage on Amazon, and EBS is in the database world. Everybody's kind of going to object storage, kind of the Snowflake model and decoupled storage and compute. It turns out that EBS is incredibly good for databases, and I'll tell you why. Because it's on a SAN, so you have storage connected over a network. What you can do is, in development, what I will typically do is spin up VMs which have like 2 vCPUs, and I can have a bunch of storage attached to them, but I'll be happily developing away. And this has hardly cost me anything because I have my cost of storage and then 2 vCPUs, like some little dinky instance size. And then when I feel like doing a test load, maybe I have to load, say, 500 billion rows, what I will do is just scale these up to be 32 or 64 vCPUs. And the cool thing about this is simply by asking for a larger, for a larger pod, Kubernetes will go ahead and allocate that for me, switch the storage, and then bang, I'm up and running. And this happens within minutes. And of course, it does a rolling upgrade, so it doesn't damage anything while it's doing it. This is really cool. So all of these things are done by operators, and at least by our operator, and most database operators that I know of are pretty similar. Some are even better. They do things like backup and stuff like that. So this is pretty cool. So far, the cattle model is actually looking pretty good. I want to talk about 3 things that were issues that, and I'm not claiming that they were really difficult issues, but there were things that we really had to think about as we were doing this. The first problem that you run into is, well, the model of everything being like a cow and they're all kind of the same really only goes so far with databases. So let me give you an example. If you have a typical distributed service, like let's take Zookeeper, which you've now heard that mentioned in 2 talks. It's something like you'll have 3 parallel services. They're all talking to storage. These are basically all carbon copies of each other with a load balancer. They're virtually identical. And what you can do is, and this is pretty common with Kubernetes, is people just create a stateful set. Does everybody know what a stateful set is? Is anybody who doesn't know and isn't embarrassed to say so? Okay, you guys all know. So it gives stable names and it handles storage claims correctly connecting. So this actually works pretty well for things like Zookeeper, which really have no differences and are just carbon copies of the same data that then automatically replicates by the application. The trouble is Zookeeper is kind of an exception, and particularly data warehouses really don't work like that. And the issue that we ran into and had to grapple with early on was that in these ClickHouse clusters, the nodes tend to be different. And there's a variety of reasons why they might be different. They might have different resource allocations because, for example, in fact, this is related to the above ones. You might have some nodes in the cluster, even though they're all the same process. You might prefer to use some for reads to do your writing, and some to be read-only copies. And as a result, you might optimize like when you're writing data in ClickHouse, you actually don't need that much memory, but when you're querying, you need a lot because joins and aggregates are held in memory during the query. So as a result, you can get different resource definitions. You can also get different use profiles, which means like the read-only copies, those can be brought up and down kind of at will, but the writer, you might only have one of them. And so you have to be kind of careful about that. Other things, we spread our databases across AZs. It's really important to be very clear that these things are landing on the right AZ. The stateful set model gives you no guarantees about that, at least as far as I can have ever been able to tell. Another interesting thing is you often run databases with different versions. So when you're upgrading, it's very common. ClickHouse has a pretty good multi-master replication system, but when you're bringing up a new version of ClickHouse, what you'll often do is you'll say, hey, I've got 3 replicas on each shard. What I'm going to do is I'm going to make the 3rd replica go to the new version. And you let that, and you do that, and you let it run for a while, and then if it doesn't fall dead, you then upgrade the rest. So for all of these reasons, database replicas have a tendency to vary, and you need to be able to be very specific about the configuration of each one. As a result, one of the things that we arrived at pretty early on was we do use stateful sets. And the reason is because you want consistent names and you want the storage to get correctly attached. Stateful set does that, but we have a stateful set per node, which at the time we made that design decision, it was like a little different from what other people were talking about and what was considered, sort of standard practice. It's worked great. And so, in fact, what happens is the replica model is really embedded in the operator under this notion of this resource we call a ClickHouse installation. So that was sort of insight number 1. We got to that fairly early on, and the reason was we had even then, helped about 100 different customers, run these things. So we had a pretty good idea of what ClickHouse had to do. By the way, if you have questions, feel free to jump in and ask them. We have plenty of time. Okay, here's another thing. Well, cows, right? What if your calf gets sick? It's pretty sad. So has anybody seen this error message in Kubernetes? Never. Okay, it doesn't. You've heard it happens in other companies.
Exactly.
Yeah. It's this is like our support team. This is their least favorite error when somebody comes. When somebody says that, hey, the pod is screwing up, what the hell is going on? And part of the reason for that is that with databases, there's kind of a traditional model for how you fix broken stuff. And I don't know if anybody's familiar with it, but it kind of looks like this. So it's the only difference between the only inaccuracy in this picture is that it's not 2 a.m. So it looks like it was during business hours. But yeah, the DBA comes in, lays hands upon the thing, and usually, back in the old days, it would, we used to run. I worked for a SaaS company in Campbell for a number of years, and we had a bunch of Oracle instances. And when something messed up, we would be logging in and on a big conference call and fixing it. Well, that model doesn't work so great in Kubernetes. And let me give you an example of something we ran into, which was typical, but really painful. We had a customer that was running a 3-shard ClickHouse installation. So they've got their stateful sets, they've got their persistent volume claims, persistent volumes allocated, service nicely load balancing, and so everything was hunky-dory until the EBS volume that they depended on right here died. And it died in a sort of bad cloud way, which was that it's still as far as the control plane, as far as the EBS control plane was concerned, it was still alive, but it was really dead. So the first step in the repair process was, well, they called us, and so we're on Slack, so we're hearing, okay, this thing is screwing up, and they said we're calling Amazon. So there was like a long, sort of delay while Amazon went in and confirmed, yes, this thing is truly dead. You will never see your data log again. So this led to a pretty painful recovery because basically our operator did not have. I mean, you can't just go in and fix these things by hand. When you adjust things with containers, what you really want to do is you want to go change the, whatever configuration files are telling you how to set up that container. and then maybe kill the pod, for example, let it go away, and then the operator will figure out how to bring it up again. The problem was that if we just killed one of these things, first of all, the storage wouldn't go away. So it would come right back up on the same bad storage. We could kill the store, sort of delete the PV and the persistent volume claim. In that case, it would come up and you'd get ClickHouse correctly configured, but it wouldn't properly move the schema across. So we're in a situation where it would sort of come up, but then it would be kind of half-baked and broken. And this was led to, it occupied the better part of a Friday afternoon a couple months ago. And what we learned from that is that operators really, this is a really hard issue. Operators need to handle failures. And the failures can be really bad and tricky. So this was volume corruption, and of the worst sort, where Amazon thinks it's alive, but it's really dead, and it's just causing things to die. But here's another example, startup. Has anybody ever hit the case where you have a pod that starts up and it takes so long to start up that Kubernetes thinks it hasn't started and just respins it? Yes. Yeah, this is a total pain in the ass. So, and so what you end up having to do is go in and fix the pod definition so that what's it called, so that the probe is, so the probe timeout is correct. You end up having to update the pod spec, metadata corruption, bad upgrades, unfulfilled resources, a favorite. If you get your taints wrong or something like that, you'll just have stuff sitting there. And accidental volume deletion is a really good example as well. So in this particular case, there were a number of features we had built into the operator which helped us. First of all, we put in, this is something that just I find paralyzing to think about. It's like, Kubernetes giveth, but Kubernetes taketh away. So if you go and just delete a PV, it's gone. I mean, there's nothing stopping you. So we built in locks. So for example, if you deleted a cluster, it doesn't actually make the PVC, the persistent volume claims, go away. So basically, if you screw up and take the entire cluster away, you won't lose your storage. In fact, it'll still be there, and you can restart the cluster even though you've taken away the resource, and it will even go find the PVCs again and connect to them. This is very good. So we had that. So we had some confidence that we weren't actually going to lose storage. Another thing that we had was the logs being accessible outside the pod. I mean, you're just dead in the water if you have to kubectl in to look at your logs. So that we had. We had the ability to change the CRD. What we didn't have was we didn't have a way, for example, to take the database out of rotation. This was another problem that we ran into, was while this thing was being fixed, it was still in the load balancer. And so as a result, apps were breaking. So they actually had to go change the load balancing that they were doing. And then we just didn't have a robust node replacement protocol. In this case, if we had had this thing of taking the database out of rotation and just saying, hey, this thing is in maintenance mode right now, and we had a feature, which we're now implementing, that if we blow away if we want to fix something with storage, we just blow away the PVC. So we blow away the PVC, that causes the volume to disappear. And then the operator should be smart enough to recognize, in this case, I need to make a new one from scratch, and I need to treat it as if I'm doing a rescale operation. This is a long story, but the point is that this is complicated. And this is something that if your operator doesn't handle it, you then end up going in and laying hands on stuff, and it is very, very painful. It's the same thing that happens when you realize you have a bad container. And there's something like that's on overlay FS that you now that you have to fix, but you can't fix it because as soon as the pod restarts, it'll be replaced by the bad stuff again. So this is a pretty, kind of a challenge. And I think one of the things that means that database operators take a few years, typically, I would think, before they handle these things well. Ours is doing okay. I mean, yes.
Good question. So something that you may find useful with testing some of this is that there's a couple projects that exist within the CNCF that are explicitly designed to follow some of the chaos processes.
Yeah,
So they'll like delete a random pod, or they'll put him into a bad state, or they'll
Right.
change you to be even more mean and say, we're going to reduce the timeouts for these things and see what happens. And so it would be good for fuzz testing, and if you run into a situation, to save that configuration so it can become part of your unit test.
that's a really good idea, and we need to do more of that. Initially when we put in like backup support, we didn't actually test it that much, and the reason was that don't take me wrong, but our users, I love them as brothers and sisters, but they delete their tables really often, so we kept having to use it, and that's why we knew that it worked. But that's not something you want to count on.
Yeah, we actually got really good success in a previous place that I was at. We got really good success with MySQL, where we had our replication set up.
Yeah.
But then what we did was we set up the maximum lifetime for any node to be no longer than 1 day. So we were constantly testing the coming and going of nodes. And so over time, once you're more comfortable, that's also possibly another technique. I don't know how long it takes you to start up, but if it's a fast startup, then maybe a pattern like that would.
Yeah, so we could do that in a testing situation in production databases. Well, obviously you weren't running these on production systems.
What is your production? Yeah.
See, that's a problem. So because data warehouses, those things, I didn't mention the size of the storage, but 10 terabytes is not uncommon.
Yeah.
So, and they often can take like a half hour to come up. That's it. We usually contact them when we recognize that's happening. We say, hey, you need to fix your app so that doesn't happen. But the databases are then cold for a long time because they need to refresh cache.
Yeah, that makes sense. And for our stuff, we would use it primarily for indexing, but then we would offload onto other systems for it. So. Yeah.
It's a tricky problem. I think messing with, this is where the cattle thing doesn't work so well. If people, and you have to be very careful about, making sure you don't do something that causes large queries.
You're still giving them names, so they're still pets up and on names, but you're getting closer to cattle.
Yes, well, Kubernetes gives them names. They look kind of like cattle names. Okay, so that's a real learning experience. We're still working our way through that. And I think, as you've pointed out, there's just like, we could do more on testing that would actually be more proactive. We actually have, because we've run these things for a while and we have customers running them, we actually have kind of a list of stuff we just know what we got to do. One
other question, changing subject a little bit. Further back, you're talking about performance.
Yes.
Do you care about NUMA alignment?
I don't personally, because that's dealt with by the C++ developers that dealt with. We do care about alignment a great deal, but more cache alignment.
Yeah, because Kubernetes has historically had a lot of trouble around alignment with, like, if you have more than one CPU, and then how do you get them so that when you bring a device online, did you get that alignment down properly at the scheduler level? Later on, maybe afterwards, if that's a space from the scheduler perspective that's useful to you, there's a few projects that are focusing on that, and we should probably have a conversation because your use case would be useful to them.
Yeah, one of the things I should say about scaling is kind of interesting. We use the default scheduler, and we did something which is kind of non-traditional, which is we fire up a VM for every database node.
Okay.
So then the reason was we wanted to be very, very sure that we wanted to avoid noisy neighbors, and the other thing was we just wanted we have some assumptions, like on Amazon, for example, EBS storage bandwidth is related to your VM type, and so if you have a VM of a certain type, then you'll get a certain amount of bandwidth when you attach an EBS volume. So we like to be able to control that kind of thing so that we know exactly what we're dealing with.
Okay, that makes sense.
Yeah, it was that was not something that was totally obvious that we should do that, but it's turned out to be very good. And the reason I think it's particularly for ClickHouse, just the way it's used, people talk about elasticity, but the elasticity in data warehouses that's important is the stuff I described where I'm developing and I want to scale up to 64 vCPUs. It's not something I do often. So the fact that we don't actually have to scale thing, like the fact that we have to wait for VM to start is not a big deal. Let me talk about a final topic, which is the cattle. So the other thing about cattle is everybody knows that cattle are not what cows originally looked like. Because, like if you were, like living in Europe 10,000 years ago, what passed for a cow was a pretty savage beast that would gore you to death if you tried to hurt it. So there's been an enormous amount. This is a Texas Longhorn. And one of the things that's kind of interesting about them is, yes, those guys. Yeah. So they were preferred for a long time because they can run free on the range. They can eat just about anything, and they don't lose all their meat when you herd them to market. So that's why they were the cattle that were used in the drives. So so these are, I'm not saying that these are particularly profound ideas, but these are some things that we've been grappling with overall in the ClickHouse community and as well as other database communities. So one of the things about databases is they typically do a lot of stuff on the file system. And typical operations that you would have to deal with would be things like configuration. You'll have some nice XML or YAML file that brings you up. Backup and restore, it's an operation very commonly where you'll go to the database level and copy data and push it somewhere else. Metrics export. So getting stuff into Prometheus databases don't come naturally built with Prometheus exporters. The effect is that if everything has to be done by down at the level of file system, you end up when you containerize these things, having a bunch of sidecars that take care of this stuff. So these are things that are going to be glued onto the pod to help deal with these problems. And it's kind of complex. What is a better model is with databases is just to have a model where you have a server and then you can manage everything off the network. And this is super useful for just all kinds of things. So obviously for metric data, I'll just take that as a simple example. ClickHouse has a built-in Prometheus metrics exporter. So you can just, and what we do with our operator is when we detect that, that the node is online, we just configure the metrics export and just forward it automatically to Prometheus. Other things, the more you can do off the network, the easier these things get to manage. Plus, you just have one simple pod. So this is something where ClickHouse doesn't do too badly, and we're getting better. And I think other databases like MySQL are pretty good in this respect too. Here's another one. The NVMe SSD is, and just as a high performance storage in general, is really critical for databases, particularly analytic databases, where you're looking for, like the Druid example we saw, you're looking for results in milliseconds. That's what we're all after. So sooner or later, you're going to want to use NVMe SSD. The problem is that your pods are going to end up being pinned to the host that has the storage. And this is just, there are solutions to this, but they're complicated. I mean, there is work afoot, and I talked to somebody after the last Kubernetes talk that yes, you can sort of make these things look as if they're network storage, but it's complicated. The good thing though is a lot of users still do this because they get incredibly low latency, particularly for hot data.
Yeah, if you put them over the network, that means you're going over the south bridge, and you lose a lot of the benefits of NVMe, where it sits on the northbound of that bridge as well. So yeah, you have to be careful with that as well.
I haven't configured it myself, but apparently you can get reasonable. I mean, you can get much better performance on than just generally better performance. What is typically done is in many databases, and Snowflake, well, actually Snowflake doesn't quite use this model, but others do. RDS uses this. Aurora does. You'll end up having some sort of shared storage layer, and that's a pretty common division to make this a separate service. And then what happens is these servers can be scheduled on any host. They have caching. They use the SSD for caching, and then they can. And then these guys can behave a lot more like cattle at that point. So they are, but the cost you pay, there's no free lunch here. If you do it this way, you're always going to get higher latency. And the reason is that, when you first check the data, you're going to have to, in order to get the speed, it has to be pulled into cache. The first time you touch it, it's not. And if you scan a lot of data, the caches will get emptied. So, and given that you're often dealing with, you might have a petabyte of data sitting down there, that there's definitely a trade-off. And then the final thing is, I think everybody, shared nothing versus, separate compute storage. there is definitely, as you're looking to create greater elasticity, having complete separation of compute and storage is a very, very good thing. And this is our model right here, dedicated storage. So if we need to scale the system up, we're going to have to create another replica, or we're going to have to create more shards. We will have to duplicate storage. It's fairly complicated, and for fast scaling, it's complicated. It doesn't work very well. This is the Snowflake model, where they have a shared storage layer, as I showed before. But what's cool about it is they can actually have multiple virtual data warehouses, which are operating on the same storage. This is a very powerful model. So, and it basically enables you to have elasticity in the sense that this might be, this might be your data warehouse that you're using for, for SaaS analytics that are being delivered to your tenants. This one over here could be, your analysts analyzing exactly the same data, but just using a different pool of compute resources. The more you can do that, the better options you have on elasticity. ClickHouse does not do this. And it's something that people are working on, but we're a long way from it. So that's it. Those were sort of the sort of some of the lessons that we've learned and are learning. So just some quick thoughts. Yeah. So database happiness. Yeah, replica models. I talked about variation. Obviously not stateful sets, but knowing that things are different. Really just do whatever the hell you have to do to fix things without using kubectl exec. You've lost when you have to do that. I mean, it still happens to us, but it's just a really, you're in for a bad time. And then access management and to the maximum extent possible storage through the network. If you can make that model work and get, the performance is adequate, that's the way to go. It's just way more flexible. And I think it kind of aligns with the things that Kubernetes does well, which is to tie together complex distributed applications. That's it. Thank you. You, sir.
Yes, dumb question about row versus column.
Yeah.
I mean, my understanding is that, I know it's been happening like 10 to 20 years, but columns are kind of a new thing. And, the old dusty databases like MySQL are like row-based. If they're, so I assume performance-wise that there are trade-offs, and they're really cool and fast for certain operations, but they fall down in other ways
Yes.
where row-based would be better.
Yes.
And maybe, so the people who originally did the row-based stuff many decades ago were not dummies. There was a reason they chose them.
Yes, there's two really good reasons to choose row storage. One is it uses less storage. So in data warehouses, because we put everything in columns, we tend to also have tables with very wide tables, and there's a lot of duplication of data. That in traditional, back in the days when storage cost a lot, that was a bad thing. So what you call third normal form, where you minimize the, like you have a single reference to each, like a key on each entity, and no duplication of data saved you storage. So that's thing number one. Thing number two, it's really good for concurrency. Particularly, like, imagine something like a shopping basket on Amazon. It's all stored in a single row. If you need to make a change to it, you go find one block in storage, you change that block, and you're done. And if it has like, and so you don't even, that's one block in one file. In ClickHouse, if you had like 15 columns in that bucket, you'd have to go open potentially 30 files to make that change. So it's terrible for updates. Data warehouses like to have very, very large chunks of data added to them. So there's definitely a trade-off. It's not like people were dummies. And in fact, this column model started to evolve in the late 80s, early 90s. It really only became prominent for most people in the last 10 years because data warehouses just became easier and more accessible through things like Redshift, allowed anybody with a credit card to run it. But it's always been out there. It's just that we see these different use cases where columns are better.
So it wasn't dumb.
It is not a dumb question. And in fact, you do not want to, like, I've been singing the praises of ClickHouse, but let me tell you, it has some problems. It does not have a complete transaction model, for example. You do not want to use it for anything where you're recording money. That's, that would not be wise. Okay, first.
Yeah, so if you want, like, for example, this is a data warehouse. Let's say I have an operational database. I want to create a change feed and start
storing data
Yeah.
from there to ClickHouse to run my reports. What's the best way to do that?
That is a really, really wonderful question, and we're actually working on that. There isn't an easy answer, and because there are multiple answers. I'll tell you what's happening in the database world right now is there's a couple of approaches. The traditional one is that you have siloed databases. So what you will do is you'll have your MySQL, for example, and then you have your ClickHouse as your analytic database. One of the ways to make that, to link them together is to use replication. And we actually have a Kafka sync connector that, yeah, so you can use Kafka, but it's complicated. And you have to dump the data, you'll have to load it. So you basically make ClickHouse become a replica, and you use Kafka as your log.
Is there any ETL tool that works with the column database?
Are there ETL tools that work with column databases? Yes, there are. But actually, what people typically do is they stuff the data into Kafka, and then they just blast it into ClickHouse. And then ClickHouse is pretty good at transforming data internally because you can make materialized views. So these views would, they basically work like triggers. So when you insert a block of data, you can then have a view attached to that table that you're reading into or writing into, and then it'll automatically run a query on it, run a transformation, and then put it in the final destination. That's typically how we handle it.
From Kafka to ClickHouse, or
Yeah, that's on the way in coming in from Kafka. So ClickHouse can read, like Druid, I believe, can read natively from Kafka. So can ClickHouse. Yes, sir.
So how do you support multi-tenancy? So does each tenant has a dedicated Kubernetes cluster, or?
Yeah, that's a great question. So with us, because we run a ClickHouse service, yes, we use a dedicated Kubernetes cluster, and we spent a lot of time thinking about that because for many applications, that's not a good model because the tenants are small. It turns out data warehouses are just big. So the overhead, which turns out to be about $50 a month of running like a Kubernetes, like an EKS cluster for each of our customers, is not that big compared to what we build them. But for many, so that's our tenant model. There's a different, I don't know if you were asking a different question.
Yeah, that's the question I asked.
Okay, great. Because there's a different kind of multi-tenancy, which is more at the database level where you have an application and you've got, like 2 million tenants and you need to represent their data in the data warehouse. That's an issue that you take care of inside the data warehouse itself. Yes, sir.
Can you go back to the sidecar?
Yeah.
Said lots of sidecars. So increasing sidecars nuisance. How do you suggest? In this also you have on the right side.
Yeah.
Also you have to have ton of agents to try trace, right?
Well, okay, let me take the metrics export, for example. So what ClickHouse did for a long time, again, I'm just using ClickHouse because I know this example. This is not the only way, but this ClickHouse used to, because it didn't have, like everybody in Kubernetes wants to have their metrics data in Prometheus, right? Or something that's like Prometheus. So, and pretty much everybody uses that protocol. So what you would run is you would run a process which would just, like if you're running on a fixed host, you would run a process which would just be looking at stuff inside the database and then putting up a network endpoint that talked PromQL, so that or whatever, not PromQL, but the export protocol. So then when you're containerizing ClickHouse, what you're going to need to do is you'll have the ClickHouse server, which will be a pod, and then you have another pod, which is the metrics exporter, which just is tied together with it in the spec and runs in the sidecar. So that means you have two things. And what you can do, what happened eventually with ClickHouse is that it now knows how to export in the Prometheus format. So you don't have to have anything extra.
That's an agent. Prometheus, it's an agent running. Agent is almost like
there's nothing running inside ClickHouse. So we simply tell.
Agent, otherwise you won't have the metrics collected, right? You don't go to the Prometheus. It's almost like a sidecar.
Well, the point is that we don't see it because all we have to do is tell Prometheus, hey, there's a data source you should be reading from, and it will just go do that.
He sees the agent. for a Prometheus agent. You have to put it in every node.
You don't, but it's not in the pod definition. It's not in the container. I mean, we actually have containers that do this. There's nothing for Prometheus running on these nodes. Because Prometheus can just do a network call and export the data. Because it just as an API call. That's what I would say. Does that make sense?
Agent versus API call.
Yes. Yeah, that's what I'm really saying. So like this is, you can view this as an agent which is running. And what we're doing is by making the server just know about the Prometheus export, then all you have to do is if you can find the server and you know what the port is, you can just go get the data directly.
Either way, the overhead is not, what I'm saying is the overhead still is there, whether it is API or the agent.
Yeah, that's true. Yeah, so you're going to be collecting some data and touching the server, but compared to other things that we do, that just doesn't take very much time or resources. So it isn't, it's just, because we only check every couple seconds or so, and it's a short query. Other questions?
We can take the rest of the questions for the networking hour. I know people are shy sometimes, so if you can stick around for
absolutely.
minutes, there's a few more slices of pizza. If anyone's still hungry, there's a couple more beers, I think, unless Hendrik drank them all just now.
Yeah.
One or two left.
Okay, he might have left you one or two. I got it. If you didn't get your shirt on the way in, I have a couple of sizes left. If I missed you, otherwise, thank you everyone for coming. Give yourselves a hand. First meetup back on the Peninsula in 2 years. Thank you, everybody. Thanks for coming. See you hopefully next month.
It's amazing how normal this feels.
Yeah, thanks everybody online too. Appreciate it.